Welcome to the program. Today we'll be covering topic 1.3, expressions and assignment statements. Take a moment to get familiar with our learning objectives and topics, and let's get started. We are going to start with our notional machine, and we have a block of code on the left. So go ahead and pause the video and read through that code and try to figure out what might be happening. Now that we're back, we are going to look through that code and break it down line by line. So starting on line 1, we are creating our method called cost calculator. And that block of code starts with that opening curly on line 1 and continues until that closing curly on line 15. Also, we have in our stack memory, we have a table named cost calculator that we can lay out all of our values. Lines 2 through 6 deal with our declaration and assignment statements that we learned in our last lesson. So we're just going to run through these really quick. We declared an int variable named num items and we initialized it to the value of 8. We can see that in our first spot in memory, we have num items initialized to our value of 8. We also declared a double variable called cost per item. Notice we are using our naming convention of using a descriptive name instead of a short name, and we are initializing that to the double literal of 1.3. So in our memory, we have cost per item, and in that actual memory location is that double literal 1.3. Then we are declaring and initializing another double variable on line 5 called tax rate, and we are setting that to the double literal 0.1. And so in our memory, we see tax rate, and it has the literal value 0.1. We'll notice that tax rate, we've done that name all in capital. That's part of our naming convention that we use when we declare something as final. Remember, final is a keyword that we can use to make sure that a value does not change value. So this variable cannot change value throughout the whole program. It's going to stay this tax because your tax rate stays consistent. Finally, on line 6, we see a little bit of a variation on that declaration and assignment statement. We are actually declaring two variables at the same time. You can do that as long as they are the same data type and these are both double. We are creating a variable called subtotal, and we are initializing that to the double literal 0.0, and we are declaring a variable called total, and we are initializing that to the double literal 0.0, and both of those are in our stack memory as well. Make sure that you feel pretty comfortable with declaring and initializing variables before you move on to our next section, which is assignment statements. This is where the new concepts come in for this lesson. Let's look at line 9 and let's just read that line. That says cost per item becomes cost per item plus 1.20. So when we look at this symbol right here, we do not say equals. Instead, we say becomes, because that is not the equal sign. I know in math you see that as the equal sign, and that means one thing is equal to another. That's not what this means in Java. This is not math. We are not working with math rules. We're working with Java rules instead, and that is known as the assignment operator. It is not the equal sign in Java. It does not mean two things are equal. It means that you are going to assign a value to something. You're going to take this value and you're going to assign it to this variable on the left-hand side. So let's evaluate this statement and see how it works. We're going to evaluate it following our precedence table below. We're going to go through our precedence table and look for any operator. So looking through line 9, I do not see any parentheses. I do not see any of our multiplicative operators, but I do see some of our additive operators. I do see this plus operator. That's the first thing that we need to handle. So we need to turn this into a single value. We have cost per item plus 1.20. In order to turn that into a single value, we need to know what cost per item is. We're going to look that up in our stack memory, and we see cost per item is 1.3. So that evaluates to 1.3 plus 1.20. That evaluates to a 2.5. Continuing working through our precedence table, we do have an assignment operator, and that shows up right there, the assignment operator. So we're saying cost per item becomes 2.5. That means assign cost per item the value of 2.5. So cost per item is no longer 1.3, it is now 2.5. It just got assigned that value. Moving on to line 10, we're going to read that subtotal becomes num items times cost per item. Work through your precedence table, no parentheses, but we do have multiplicative, we do have that times, so that's what we need to handle right now. Num items times cost per item. That needs to evaluate to a single value. So num items evaluates to an 8. So we have 8, and then we have our times, and then cost per item, which is no longer 1.3, it is now 2.5. So we have 8 times 2.5, and if I'm doing my math correctly, that evaluates out to a 20.0 because we have a double in there, so that's going to evaluate to a double, 20.0. We don't have any additive operators in there, but we do have our assignment operator. So now we need to handle that. Subtotal gets assigned the value of 20.0. So now we go to our subtotal, and we're going to assign that the value of 20.0. Looking at our last assignment statement on line 11, just reading it, it reads total becomes subtotal plus the quantity of subtotal times tax rate. We have to look through our precedence table, starting with parentheses. We do have a group of parentheses, so we need to handle everything inside that parentheses following the precedence table. So inside here, we would look for more parentheses, which we don't have. Then we look for our multiplicative, which we do have. We have a times. So let's handle that. Subtotal. Subtotal is going to evaluate to a 20.0 because that's what it got assigned in the previous statement. So this is 20.0 times our tax rate of 0.1. So that's going to evaluate to a 2.0. Continuing looking at the rest of the statement and continuing down our precedence table, we do have additive. We do have the plus operator. So we have subtotal plus. Subtotal is still 20. So we have 20.0 plus 2.0. That's going to evaluate to a 22.0. And then finally on our precedence, we have our assignment operator right here. Total becomes that evaluated value. That evaluated value is a 22.0. So total is going to be assigned that value. So total becomes 22.0. On line 14, we have a system method call, system.out.println, in which we print out the total. Looking at our stack memory, total is 22.0, and since this is a println, that means the cursor will be waiting right here at the beginning of line 2. Make sure that you feel comfortable with that code before moving on to the next section. Our next section is arithmetic expressions and precedence. We have 2 learning objectives. We want to be able to evaluate arithmetic expressions in a program code, and we want to evaluate what is stored in a variable as a result of an expression with an assignment statement. So we said there were 3 steps in a program: data in, data processed, and data out. Take a second and look at this block of code and see if you can identify when and if any of these steps appear in that program. Starting with data in on lines 3 through 6, this is where we see some data in right here. So we're not actually getting data in from the user, but this is a place where we can come in and change some of these values. This is kind of where the data comes into our program at. Step 2 is data processed. That's on lines 9 through 11. We are processing that data. We are doing some math. We are evaluating some of those values. And then data out shows up on line 14 where we put that information onto the screen. So this program does feature all three of those steps: data in, data processed, and data out. So no matter what step we are doing, we are evaluating expressions. Every single line on here is an expression. An expression is just a piece of code that will be evaluated when it is run. We've been evaluating expressions since we started looking at code. We're going to further refine this and we're going to talk about arithmetic expressions. So we just want to look at any length of ints and doubles connected with arithmetic operators and grouped with parentheses. So this is going to be a subset of expressions, an arithmetic expression. Now it's talking about arithmetic operators. Our arithmetic operators are operators that perform arithmetic operations on groups and numbers. And we have 5 arithmetic operators. We have plus, minus, multiply, divide, and modulo. So look at our code and see if you can identify where the arithmetic expressions are. So we have 3 arithmetic expressions. The first one shows up on line 9, and then another one shows up on line 10, and another one shows up on line 11. It's everything to the right of the equal sign of those expressions. So 9, 10, and 11 by themselves are expressions, but inside those expressions we have arithmetic expressions. And so we said they are arithmetic expressions because they feature arithmetic operators. So we have our 5 operators. I didn't include a column that describes what these operators do because we've been using these operators for a lot of our lives and we know what most of these operators do. The one that we might not really know is the modulo operator, but we have a whole section later that talks just about the modulo operator. So what you should notice that there is no arithmetic operator for exponents. Now I know sometimes you can do like that little up arrow, that caret that's on the 6 key of your keyboard, but that's what you do in math. That's what you do in calculators. Remember, this is Java. This is something completely different. Just because you can use that symbol in different places doesn't mean that you can use it in Java. Java does not have an operator for exponents. We have a completely different way that we have to handle exponents. And whenever we create arithmetic expressions, they will be evaluated to a single value. That's super important. So that leads us to our essential knowledge. The arithmetic operators consist of plus, minus, multiply, divide, and modulo. And during execution, expressions are evaluated to produce a single value. So we have some simplified code right here. We are declaring 3 integer variables A, B, and C, and we are initializing those to the integer literals 5, 3, and 8, respectively. And then we have an arithmetic expression on the next line, on line 2. We just want to pay attention to that arithmetic expression, and we want to know how to evaluate it. We want to evaluate it and we want to evaluate it down to a single value. That's super important. I'm going to put that up there and I'm going to pin that up there for a while. Expressions in Java are evaluated to a single value. We want to keep evaluating that arithmetic expression until it is one single value. So now that we have that arithmetic expression, how do we evaluate it? Do we take it and just like plug it into Google and try to give it an answer? I'm sorry. You'll have to excuse her. This is my Aunt Sally. In fact, I feel like a lot I have to say, please excuse my dear Aunt Sally. And that's one of those things. What are those things called? A mnemonic or a neutronic? Yes, right. That's a mnemonic. Yes, correct. That's also another mnemonic device. Thank you. Yep. Yeah, that's a little messed up. So this one is the mnemonic to remember our order of operations in math. So we evaluate parentheses first, exponents, multiplication and division, and addition and subtraction. But that's how we do things in math. We need to change this a little bit for how we do things in Java. So in Java, we don't have exponents. And we have something else instead. We have modulo to go with multiplication and division. So we're actually not excusing my dear Aunt Sally anymore. Great, I'm going to have to hear about that later. So this is our precedence in Java. And so we're going to throw this into a table to make it look a little bit nicer for us. But we have to remember that expressions in Java are evaluated to a single value, and we need to tack on this new according to the rules of precedence. We always need to follow precedence when we are evaluating. So this is what our table looks like. Parentheses gets evaluated first. Then our multiplicative, our times, divide, and modulo all happen left to right in order that they are there. And then finally, addition and subtraction. Those are our additive operators. Those get evaluated last in our arithmetic expressions. So operators are evaluated from highest level to lowest level of precedence. And you can see our levels are 16, 12, and 11. You might be asking why they're not 3, 2, and 1. Well, because there's a lot of other operators in Java that fit in between these and actually below these, and we will build this precedence table as we go. So again, precedence means specifying the order in which operations are evaluated in an expression. So let's go ahead and evaluate this arithmetic expression according to the rules of precedence, our precedence table. Precedence says find parentheses first. So we have a set of parentheses here, and we also have a set of parentheses here. They are both at the same level, so we evaluate those from left to right. So we evaluate this one first, and then we're going to evaluate this group second. Now, we already took care of declaring and initializing our variables. We have all of those in our table in memory, so we can refer to those when we need those values. So we're going to look inside this first group of parentheses, and now we need to evaluate that according to precedence. So inside that group, there are no parentheses. Now we need to look for our multiplication, division, and modulo. We have multiplication right there. That's going to be the first thing that's evaluated in there. So let's go ahead and figure out what these values are. We have an A, which is 5, plus our B, which is 3, times our C, which is 8, plus an integer literal of 1. So that multiplication happens first. So we have 5 plus 3 times 8 is 24 plus our 1. Next on our precedence list, we have our additive, that's our addition and subtraction. And we have two addition operators. We have this one and this one. They're both at the same level, so we do that left to right. So we start off with the plus on the left. We have 5 plus 24, which gives us 29 plus 1. Now we can handle that last plus. This whole side evaluates out to 30. So in this parenthesis, that whole thing evaluated out to 30. We have divided by, but now we need to handle the second group of parentheses right here. We have C minus B. C is 8, B is 3. 8 minus 3 is 5. And we still have our minus 2 on the end. So we have 30 divided by 5 minus 2. This is our last pass through our precedence table. First look for parentheses, we don't have any. Then we have our multiplicative, We do have a divide in there. We have 30 divided by 5. 30 divided by 5 gives us 6 minus 2. Continuing through, we have our minus. We have our 6 minus 2, which is 4. And so this whole left-hand side evaluates to the value of 4. Then we have our assignment statement, and that gets put into the variable of a. A changes its value and becomes 4. Notice how B and C don't change. By doing math on B and C, that doesn't change their values here. We just evaluate their values so that we can evaluate this arithmetic expression. That gets us our essential knowledge. Operators can be used to construct compound expressions. That's what this is, a compound expression. It uses a lot of those arithmetic operators to make one big, long expression. During evaluation, operands are associated with operators according to operator precedence to determine how they are grouped. That just means we use our precedence table when we evaluate that arithmetic expression. Our next section is titled Assignment Statement, and we get to learn a new statement. Our learning objective is evaluate what is stored in a variable as a result of an expression with an assignment statement. So in the Secret Box episode of SpongeBob SquarePants, SpongeBob wanted to see what was inside Patrick's secret box. And what he had in there was a string. And just like Java, we can store strings or other data in variables. And we saw a variable is just like a box in memory. So that sound means that we are going to learn a new statement. This statement is the assignment statement. It is a statement used to store or assign a value in a memory location. We call those memory locations variables. So we start off with the identifier or the name of the variable, and we set it equal to an expression. So you'll notice that equal sign is colored red. That's because that is the assignment operator. It is an operator used to assign a value to a variable, different than how we use the equal sign in math to mean equality. So from our examples, you see variables on the left, quantity, and then we have our assignment statement and a value on the right, 4. Price is equal to 0.89. Is delicious is equal to true. So some things about that assignment operator. The first time you assign a value, it's called initializing the variable. That's when we use it in our variable declaration and assignment statement. Variables must be named and initialized before being used, and variables can change value after they are initialized. So looking at some code, on the top we have our variable declaration and assignment statements. We have seen these before in the previous lesson. I'm just going to point out that there are assignment statements in here. We have seen assignment statements before because this is a combination of two statements. It is the variable declaration statement, which is this part, and the assignment statement. So we kind of just mashed two lines of code together. So we're just going to be looking at the ones on 8 and 9, which are just solely assignment statements. So we've already taken care of our variable declarations and assignments and put everything into memory. So looking at our assignment statements, we have our assignment operator on line 8. It's right here. On the right-hand side, we need to evaluate that expression to a single value. It already is a single value. It is the integer literal 5. And so the assignment statement means we're going to assign that to this variable. We're going to say batches becomes 5. So if we look up in our memory, we have batches right here. And instead of 4, now that is going to change to a 5. So when we read that assignment statement, we can read that as becomes. And then now looking at line 9, we have our assignment statement right there. But we have an arithmetic expression on the right, which we need to evaluate to a single value because this multiplication sign has higher precedence than our equal sign. So batches is now a 5 when we evaluate it on this line of code, times our batch size, which is 12. 5 times 12 is 60. And now we get to use our assignment statement. Our assignment statement says num cookies becomes 60. Remember, we can read that as becomes. So 60 goes into num cookies. Num cookies now changes to 60. That aligns with our essential knowledge. The assignment operator allows a program to initialize or change the value stored in a variable. The value of the expression on the right is stored in the variable on the left. We want to pay attention to this common programming mistake over here on the right. Only specify the data type in the declaration statement, not in the assignment statement. So notice when we declared batches up here, we had to say it was an int. When we use batches the next time, we don't say int again. We don't put int there a second time. When we say int, that's telling us to make space in memory so we can store batches. Well, batches is already in memory. We don't want to say int again because we don't want another space that we're going to try to put another batches. That would be wrong. You only use the data type when you are declaring the variable, when you are making space for it in memory. Once it's already in memory, you don't say the data type again. So in front of num cookies down here, we don't say int again because we already declared it as an int on line 2. Java already knows it's an int. Java already made space in memory, and Java already put it in memory. So only use the data type in the declaration statement, not in the assignment statement. Sometimes I write things on the screen and then I look at it afterwards and I wonder how anybody learned anything from what I wrote. Our next lesson is data types and integer division. We have two learning objectives. We need to evaluate arithmetic expressions in a program code, and we need to evaluate what is stored in a variable as a result of an expression with an assignment statement. Looking at the code on the left-hand side on line 2, looking at that arithmetic expression score plus 10. In that arithmetic expression, we have an integer variable, we have our plus arithmetic operator, and then we have an integer literal. Whenever we add an int to an int, that's always going to evaluate to an int. If we have an int minus an int, it's going to evaluate to an int. Same thing with an int times an int, and same thing with an int divided by an int. It will always evaluate to an int. That lines up with our essential knowledge. A literal is the source code representation of a fixed value. So that 10 in our source code, that is a representation of the fixed value of 10. That is an int literal. Arithmetic expressions include expressions of type int and double. In this one, we have int and int. And when we have an arithmetic operation that uses two int values, it will evaluate to an int value. So that means the value of an expression has a type based on the evaluation of the expression. Might sound super simple, might sound super obvious. There's one place where a lot of programmers get hung up on this. So we're going to look at these 4 blocks of code. On the top left, we have int score is equal to 8. We have score is equal to score plus 10. What do you think the value of score will be when we print out score? That's going to be an 18 because score was 8. We added 10 to it and it became 18. So when we print it out, by the time we print it out, score will have an 18 in memory. On the top right, we have int health is equal to 100. Line 2 says health is equal to health minus 25. Yes, I know a couple of seconds ago that said health plus 25, but through movie magic, now it says minus 25. What is going to be the value of health when that prints out? Hopefully you thought 75, that is correct. Health started off at 100. We subtract 25 from it, it becomes 75. Gets stored back into that health variable. By the time we look at it on line 3, it is now 75. Multiplication on the bottom left, int cookies is equal to 15. Cookies is equal to cookies times 2. When we print it out, we have 30 cookies. Started off with 15. 15 times 2 is 30. Put it back in that variable. And our last one, int magic is equal to 15. Magic is equal to magic divided by 2. What's going to be that answer when we print out magic? Did you say 7? Or did you say 7.5? Now this is where people get hung up. I told you it seemed pretty easy and the first 3 were probably easy. This is where the tricky part comes in. So when we declare a variable of type int, Java goes to stack memory and it gets us a space the size of an int, which is 4 bytes. We give it the name of magic, and so then it labels that space in memory magic. And we initialize it to the value of 15, and that's fine. 15 fits perfect in that box. Then on the next line, we say magic is equal to magic divided by 2. Well, 15 divided by 2 is 7.5. 7.5 is not going to fit in that box. It is too big. That box does not have space for decimal places. So what happens when we try to put that in? Our essential knowledge says an arithmetic operation that uses two int values will evaluate to an int value. That's going to evaluate to a 7. We had an integer divided by an integer. It's going to give us the answer as an integer. This is known as integer division. When you divide two integers, it's going to return the integer part of the result. It doesn't round. That zero point 0.5 gets truncated. That means it just gets thrown away. Now, in this example on line 3, we have items, which is a variable that was declared as an integer, and we are multiplying it by price, which is a variable that was declared as a double. An arithmetic operation that uses a double will evaluate to a double value. So as long as there is one double value in your arithmetic expression, the entire arithmetic expression will turn into a double. It will evaluate to a double. So here we see some blocks of code, and all of them feature int magic starting off at 15. So we have an integer in each one of those expressions. The first one on the top left, magic is an integer, and 2 is an integer literal. So that's going to print a 7 to the screen. We saw that because that's integer division. On the top right, we have magic, which is integer, divided by 2.0, which is a double literal. Now, although you might think it is the same value as in the one on the top left, the one on the top left is an integer literal. 2 is an integer literal, 2.0 is a double literal. One of those two things in the expression is a double, so that whole expression on the right will evaluate to a double, and we will get the answer 7.5. Same thing on the bottom left, 2D is another way of writing 2.0. So we have an integer divided by a double. We're going to get our answer as a double. And same thing on the bottom right, 2 lowercase d is another way of writing that double literal 2. We have an integer divided by a double. We'll get our answer as a double. So on the left, we have some variables declared, 2 integers, 2 doubles. On the right, we have some statements. And so we want to evaluate these statements using our rules that we just learned. Our first one, we have I1 plus I2, which is just the integer 4 plus the integer 6. We're going to get the answer as an integer. That's going to be the integer 10. The second statement is I1 plus D1. I1 is the integer literal 4. D1 is the double literal 6.0. One of these things is a double, so the answer is going to be a double. This is going to be a 10.0. So these two do not give the same answer. The integer 10 is different than the double value of 10. The third one, we have D2 minus I1 divided by I2. So D2 is 22.4 minus I1 is 6 divided by I2 is 4. The first thing that's going to happen in this statement is the division. We're going to have 6 divided by 4. 6 goes into 4 one time, and then there are some decimals afterwards, which I think is 1.25. Don't quote me on that. It doesn't matter because we did an integer divided by an integer. It's going to give us only the integer part of that answer, which is 1. So then we have 22.4 minus 1. We have a double minus an int, so the answer is going to be a double. It's going to be 21.4. Last statement is the quantity D2 minus I1 divided by I2. So now we have some parentheses to do some grouping. In that group, in the parentheses, we have 22.4 minus 6, and then we have that divided by 4 outside of the parentheses. The parentheses happens first. We have a double minus an integer. Since we have a double anywhere in that expression is going to evaluate to a double. 22.4 minus 6 is going to evaluate to 16.4. Then we have 16.4 divided by 4. So we have a double in here. So the answer will evaluate as a double, and it evaluates to 4.1. Make sure that you are very comfortable working with different data types while evaluating expressions. Our next topic is modulo division. That is our fifth arithmetic operator that I told you earlier we would get to. This is the whole section for dealing with modulo. Our learning objective, evaluate arithmetic expressions in a program code. So you're a baker, you bake cookies. Each box holds 12 cookies. So the number of cookies you make, your batch size can vary depending on the amount of ingredients that you use. You need to quickly calculate how many boxes of cookies you will have and how many extra cookies you will have when you alter the recipe, because when you are trying to sell cookies, you don't want to have a bunch of leftover cookies. You're wasting ingredients. So you bake 24 cookies. Each box holds 12 cookies. How many boxes will you have? And how many cookies will you have that don't fit in any boxes? Well, if you bake 24 and each box holds 12, you will have 2 boxes of cookies and nothing left over. That's perfect. You sell everything that you make. If we move up to 28 cookies, how many boxes, how many remaining? Well, we would have 2 boxes that holds the 24 cookies, and you would have 4 extra cookies that don't fit in a box. If we bake 30 cookies, 2 boxes, 6 left over. If we bake 35 cookies, 2 boxes, 11 left over. Each box holds 12, you have 11 left over. So if we go from 35 and we go up one more to 36, you will have 3 boxes and 0 cookies remaining. So if you bake X cookies and each box holds 12, the minimum remaining is 0, the maximum remaining is 11. So when you divide a number by 4, your possible remainders are 0 through 3. Because if you had 4 left over, it could just go into that group again. If you had 5 left over, you have more than enough to make a group. If you divide something by 10, your possible remainders are 0 through 9. If you divide by any number n, your possible remainders are 0 through n minus 1. Your remainder can never be greater than or equal to your divisor, because if it is, you could have divided in another time. So the modulo operator gives us the remainder after division. So if we have 7 mod 2, and that's how we say modulo, we just say mod, 7 mod 2, we want to know how many times 2 divides into 7. And we know that 2 goes into 7 3 times, but that's not the answer we want. We want the remainder. So when 2 goes into 7 3 times, that's 6. That leaves 1 remainder. 7 mod 2 will give us the answer of 1. What do you get when you do 14 mod 4? Well, 4 goes into 14 3 times. That gets us up to 12. That leaves us with a remainder of 2. So 14 mod 4 is 2. And 22 mod 6. Well, 6 goes into 22 3 times. That gets us up to 18, which then leaves us a remainder of 4. So 22 mod 6 is 4. So that's it. That's modulo. That's what it does. Oh, so you want to know what to do with it. You don't want to just know what it does. All right. There are really 2 things that you need to know that you can do with modulo. So here we have a series of expressions on the left. So we're taking some number starting with 0 and then counting up 1, 2, 3, 4, 5 every time we are modding it by 2. Look at the answers that we get when we mod it by 2. 0 is an even number and we mod it by 2, we get 0. 2 is an even number, modded by 2, we get 0. 4 is an even number, modded by 2, we get 0. Because 2 always divides into an even number with no remainder. When we look at our odd numbers, 1 mod 2 is equal to 1, 3 mod 2 is equal to 1, 5 mod 2 is equal to 1. Whenever we divide an odd number by 2, we're going to get a remainder of 1. Remember, when we're modding by 2, our only possible remainders are 0 and 1. So if we have an unknown value of x, if we mod that number by 2 and get a 0, we know x is even. If we mod that number by 2 and we get a 1, we know x is odd. That's the odds and evens use for modulo. If you don't know what the number is, you can determine if it's even or odd. Oh, you're not impressed with that example? Okay, let's look at example 2. In this example, you'll notice that in our expressions, we are modding every expression by 10. When we mod by 10, we can only get answers 0 through 9. So when we mod 7 by 10, 10 goes into 7 0 times with a remainder of 7. 32 mod 10, 10 goes into 32 3 times with a remainder of 2. 2681 mod 10, well, 10 goes into 2681 268 times with a remainder of 1. You'll notice that these numbers, the 7, the 2, and the 1, those are the numbers in the ones place. So whenever you divide a number by 10, the possible remainders are 0 through 9, and that remainder is the number from the ones place. Still not impressed? I don't know what to tell you. Those are the two examples that you need to know of what you use modulo for. We finally made it to our last topic, exceptions. Our learning objective, we want to evaluate arithmetic expressions in a program code. There are times where you might need to write a paper, and when you write the paper, you might make some errors while writing that paper. And those errors are classified in a couple of different ways. You might make spelling and grammar issues. And so when you type that into a word processor, they will identify those spelling errors for you by putting a red lightning bolt under those words. Sometimes you might just have the wrong content. Things could be spelled correctly, but it's not the proper word or it's not the proper information. So we classify those as two separate types of errors, spelling and grammar errors, and we also have content errors. Well, the same thing happens when we code. We can have syntax errors. Those are errors that occur when we are trying to type the code into the program. And then we can have runtime errors where we type code that is technically correct, but it doesn't work the way that we meant for it to work. So we typed in lines that are proper lines of code, but our algorithm, our thought process isn't correct. So we're going to be looking at syntax errors, errors you make when you are typing in code. Now, these errors are usually identified before you even run the program, and they are usually identified as the same way as your spelling errors in a paper. They will put a red lightning bolt underneath them, and when you put your mouse over them, they will tell you what you did wrong. So in this case, it specifically told you your string literal is not properly closed by a double quote. We started our string literal hello world, but we never closed it with a quote. When you are typing your program, it tries to be super helpful to try to catch these syntax errors for you. Here's another one. It tells us expected semicolon. We never put a semicolon at the end of this one. Here's another one. Incompatible types, possible lossy conversion from double to int. We were trying to put an 8.0 into an integer. We're putting a number that's too big in a box that's too small. Here's another one. It says error cannot find symbol and it points right to where it is. It's pointing to where we have our dot print. That says dot print n. We don't know a dot print n. We know a print and we know a print ln, but we don't know a print n. One more, error cannot find symbol, and it even tells you the symbol variable qty. So that's telling us that we are trying to use a variable that we never declared before. So these are all errors that we made when we were typing the code into the program. Runtime errors are errors that happen when you run the code. And there's one very specific runtime error that you might run into. and it happens when you are creating arithmetic expressions. Now we have a number divided by a number. And this arithmetic expression works for a vast majority of the numbers that you can think of. But there is one number that you can plug in for num1 or num2 to make it so that you cannot solve this arithmetic expression. In math, we know how to do a lot of things. We can solve a variety of expressions, but there is one expression that we do not know how to do, and that is we do not know how to divide by zero. So if num2 is 0 and you try to divide by 0, we don't know what's going to happen. We don't know what happens when you divide by 0. Java will flag this as an error when the code is running. When it gets to this line of code, it's going to say, hey, num2 is 0. Even I can't divide by 0. And so you get what's known as an exception. An exception is a problem that occurs while a program is running that causes it to crash. And specifically, we are doing an arithmetic exception. And that is thrown when the program takes exception to an arithmetic expression. For example, an integer divide by zero operation. So you can see Java gives us the message arithmetic exception divide by zero. In fact, divide by zero is the only way that I know to cause an arithmetic exception. I don't know any other arithmetic exceptions. So here you will see a program that will cause that exception. You can type all this in and it will not give you any syntax errors because Java does not recognize any errors in here because it doesn't know that num2 will be a 0 when you get here because this is a variable. A variable could change values throughout the program. So it doesn't know that you are trying to divide by 0 until it actually runs the program and evaluates that as a 0. So our essential knowledge, an attempt to divide an integer by 0 will result in an arithmetic exception to occur. What that means is that the computer gets offended and it's like, I take exception to that remark. Good day, sir. And it just stops your program. So exceptions will stop your program from running when it gets to that point in code. Everything above that will evaluate fine, but once it gets to that exception, it will throw that error, it will output that message to the screen, and it will stop trying to run the rest of your program. Woo, that's going to get us to the end of this lesson. Make sure that you review how you feel about those learning objectives. Read over those recap statements. Make sure that you hit me up with any questions or concerns that you have regarding this content. Join us in the next video and keep programming.